that we're going to do is we're going to re-jog our memory on exponents and powers. So this would be our coefficient and this number would be our power. The power basically signifies how many times you would multiply the coefficient by itself. For this case, it would, you have 3, so you would multiply 3 by itself one time, so that would be 3. The next example has 3 squared, so that's basically 3 times 3 because you're multiplying the variable by itself twice. So 3 times 3 would be 9. And another thing to remember is that when you have a variable or coefficient and you're multiplying it by itself to the 0, it will always be 1, no matter what number.
Okay, that's it.
So, for solving roots, basically all you would do is you'd find what number multiplied by itself a certain amount of times would equal the number within the radical. So, for solving a squared root, pretend that there's a 2 there. That's what it means to square it. And basically what you do is you find what number multiplied by itself twice would equal 9. What times itself twice would equal 9 would be 3. 3 times 3 equals 9. And then when you want to solve the cube root or any other number, what you would do is you'd see what number multiplied by itself that many times would equal the number within the radical. For our case, it would be 3. So you want to see what number multiplied by itself 3 times would equal 8. For our case, it would be 2. 2 times 2 times 2 equals 8. Alright?
So instead of this, we're going to have the negative 27 with 2/3. So 2/3 power. So what we do is we put it back in the parentheses, we draw the radical. Really, we're going to be cube rooting the negative 27. And we get a negative 3 times a negative 3. I'm sorry, this should actually be negative as well. You get a negative 3 times a negative 3, which equals a positive 9, times another negative 3, which equals a negative 27 right here. So we cube rooting the negative 3. Then again, because the 2 is right here, always have the numerator on top, whatever the numerator is, you bring it outside the parentheses squared. So it's a negative 3 squared, which is also nice! Alright, so because our group's a little lazy, anyway, so we wanted to try and just knock out the powers at the same time. So we're doing product of powers, power of power. Well, with the product of powers, the bases are the same, like in this case we have a y to the third and a y to the sixth. Since the bases right here are the same, we can simply add these items. So while doing that, we then get y to the third power plus 6, while also having 6x squared on the inside. So when you do that, we get 6x squared y to the 9th power. Then with the power of power, we're distributing this outside power, and we're bringing it to affect all of the variables on the inside. So our next step would then become 6 to the 4th power, x 2 times 4, y 9 times 4, which gets you up to a whopping 1276 x to the 8th power y to the 6th.
So for our equation, we have square root of 25x squared y to the y to the 6th and times z. So the first thing that we do is we try to factor anything to make it in its simplest form. So 25 would be 5 times 5, and we break down the x's. So we have x times x. We break down the y, which would be 6y and 1z. Now, because we have this 2 right here, what we want to do is we want to take everything out that has 2 of them. So basically, you have 2 5s, you have 2 x's, you have 3 pairs of y's, and then you have the z that's left all by itself. Anything that has 2 of them, because you have that number 2 right there, you take out. But you only take out 1. So you take out 1 5, you take out 1
1 5.
You would take out 3 y's, and you would leave that z in there. Now we can simplify this. Well, you don't really need to have that squared right there, because that's what, you don't need to have the 2 there, because that's what it means when you have nothing. So, you have x
y's would be the same as y cubed. That should be a z. And that's how you solve it.
Alright, so with our next problem here, we have 5yz to the cube root of 9x, 3y to the fourth, times 2y to the cube root of 3x to the third, y to the third. So, with this, because it is this kind of problem where it's sort of the same base sort of thing going on here, you can immediately take these and you can multiply against each other to simplify down to 10y squared z. To the cube root of 27x to the 6th power of y to the 7th. So what you then are going to do is you're going to have 10y squared z with all these like kind of simplified out to show how, because like 3 is the security arc, because as you know, you don't want to break out in terms of 1 or anything like that. You always got to break out in terms of 3 or 2, so it's something like that. So with that we have 3 to the 3rd power, which brings us 27. So because there are 3 3s, we can bring it to the outside. There's 3 x's in this one, 3 x's in this one, so we pull both out, all 6 x's out. And then with the 6 y's, we can also pull them out. Unfortunately, there's 1 y left by itself. So the new equation will become 10 times 3 x squared y to the 4th z, while there's still a cube root of y, which will bring us to our final answer of 30x squared y to the 4th z cube root of y. Problem we had, how long David was in the air after his jump? What was his height after 0.5 seconds? So, knowing that our formula is t equals 0.5 to the square root of h, we then go 0.5 equals 0.5 to the square root of h. You divide 0.5 by both sides because you want to isolate the variable. So when you do that, you're then going to have 1/2 divided by 1/2, which you then go into equal 1/2 times the reciprocal of 1/2, which is 2, equals 2/2, which is also equal to 1. So after that, you want to get rid of the square root right here, or the square root. So you square it on both sides to get rid of it. And 1 times 1 is still 1. So the height after 0.5 seconds is
So now we're going to see what the height would be in 1 second. So 1 equals 0.5 square root of h, and you divide it by 0.5. And then 1 over 0.5 equals square root of h. And then 1 over 1 divided by 1/2. Then you do this reciprocal of that. So it's 2 over 1, which equals 2. And 2 equals square root of h, and then you have to square it on both sides, and h equals 4.
Find David's height at 2 seconds. To do this, we need to put 2 into our equation. So 2, which is replacing t, our time, would be equal to 0.5 times the square root of h, which is the height. The next thing that we would do to isolate the variable, which is the height, would be to divide by 0.5 from each side. After doing this, we would have 2 over 0.5. To solve this without using a calculator, what we would end up needing to do is write it out as fractions. So we'd have 2 over 1, which is the same as 2, divided by 1/2, which is the same as 0.5. to divide these, what we would need to do is we would need to multiply and flip them using the reciprocal. So we'd end up having 2 over 1 times 2 over 1, which is the same thing as 4. Now that we have 4 is equal to the square root of h, we need to get rid of that radical sign. So what we need to do is need to undo the square root by squaring it. And after squaring 4, we'd end up with 16. So our David's height at 2 seconds would be 16 feet.